Good afternoon once again. It's Ishola Adedeji Michael and it's this Success Enlightenment. Today we'll be looking at a 100 level economics course, mathematics for economics. It's a 104, it's a second semester course. I'll be working with the University of Abuja course applying for this course. The last semester students were taught it's a 103. There they were introduced to Introduction to Mathematics for Economics. This is a continuation of ECM 103. And here the discussion focus will be on four major topics in mathematics for economics, four major topics. A mastery of these topics is very, very essential for a student who want to have a successful undergraduate experience in economics and further its education into postgraduates. Now, to be a professional economist, it is important to have a mastery of what? Calculus. Have a mastery of calculus. So here we'll be discussing the two major branches of calculus, which is what? The differential calculus and the integral calculus. In further studies in 200 level, we'll be talking about the application of these. We're focusing majorly on the application of these in economic analysis. But for now, we'll be discussing differential calculus, integral calculus under what? Calculus. Then the second topic, we will continue our discussion on what? Matrix. Now, in our first semester, you are introduced to matrix and determinants, which you have a foundational knowledge on matrix and determinant. So now there will be a continuation on matrix and determinants. You know, working on how to apply the knowledge and inference of matrix in economics analysis. And furthermore, after that, we'll be discussing the input-output analysis. This is very, very important. It's very, very important because major production decisions related to cost are being analyzing input-output analysis, and this comes under the jurisdiction of what? Economics what? Science. So input-output analysis will be the third topic you'll be looking at, and the last topic you'll be looking at in this course will be what? Game theory. Game theory is very, very important to be economics as it is largely applied in microeconomic analysis. It's largely applied in microeconomic analysis, especially in the decision making of duopoly or oligopoly market. So once again, we'll be discussing calculus, matrix, input-output analysis, and game theory. We are going to start with the introduction to the first topic, which is what? Which is calculus. And under calculus, we start by discussing the meaning of calculus, division of calculus, nature of economic variables. For every student out there, the recommended test, especially for students from University of Abuja and the entire economics students in Nigeria, we have mathematical economics for fresher and sophomores in economics, management and social science by Okorafor Undwekalu David, copyright 2021. Get this test, and this test will actually make this course very, very easy for you. Very, very easy for you. What is calculus? Calculus is simply a branch of mathematics that is concerned with the differentiation and integration of variables of concern. Now, we have studied during your economic studies, you treat so many variables such as GDP, the gross domestic products, national income, unemployment, inflation. Definitely, each of these variables has what they depend on. Take, for instance, the demand and supply function that is very, very popular. We know that the quantity demanded of a commodity is a function of the price, and also the quantity quantity supply of a commodity is also a function of the price. So these are variables. Now, in calculus, we are looking at what? We are attempting to integrate or differentiate the variables we are studying. Now, what do we mean by that? Let's take, for instance, here, let's use the demand function for our case study. Let's use demand function. The demand function states that the quantity demanded is a function of price. Certainly variables, right? The quantity demanded is a function of price. Here, the quantity demanded will be the what? The dependent variable. Why? The price here will be the what? Independent variable. That is, it is the change in price that affects, that forces quantity demanded to change. If there is no change in price, the quantity demanded is remain constant. Change in quantity demanded never occurs except there is a change in price. That is what this means. So this is a function, but this function we can transfer it into what? Into an algebraic equation. We can transform it to what? Mathematical form. Now, for us to do that, our basic understanding from that very theory of law of demand, which says that the higher the price of a commodity, the lower the quantity demanded. By this law, it is established that when the quantity demanded is increasing, the price must have been reducing. That is, for quantity demanded of a commodity to have increased, the price of that commodity must have reduced. By that, we see that the quantity demanded and price are inversely related. They are negatively related. By having that understanding that the quantity demanded of a commodity and the price are negatively related, then you can go on and transform this to what? To an equation. Nothing. The very basic pictures of equation. Here it will be a linear equation, definitely. Now, basic function of this, basic element of this equation be number one, you have what we call the what? Independent variable. Two, you are going to have what we call dependent variable. You have the what? The intercept. Then you are going to have the what? Slope. These two are called what? The parameters. They are called what? Parameters. Now, what am I saying? We are going to have the what? Independent variable. Now, independent variable is that variable that causes a change in the other variable. In this case, when you look at it, which of these, we have two variables here. We have quantity demanded represented by what? QD, and we have price here represented by what? P. Now, which of these variable causes a change in the other? We obviously see that it is the prices that influence what? Quantity demanded. When prices does not change, quantity demanded is maintained. But as prices increases, what happens to quantity demanded? The quantity demanded also what? Reduces. And as prices reduces, what happens to quantity demanded? The quantity demanded what? As prices increases, quantity demanded what? Decreases. Now, by so, we already identify our what? Our independent variable to be what? P. To be P. Now, the dependent variable is the variable we are studying. It's the variable we are trying to evaluate the magnitude of change that occurred in that variable as a result of a change in another variable, which is what? Independent variable. Are you getting it? Now, the dependent variable is the variable we are trying to what? We are trying to study. Here we are trying to study what? Quantity demanded. That's what we are trying to study. We are trying to study what? Quantity demanded as it is being influenced by what? The price, which is the what? Independent variable. Here in this case, the dependent variable is what? QD. Now, we have now have what we call intercept, and we now have what we call slope. We call those two what? Parameters. Now, intercept and slope. If you recall in your knowledge of what? Basic what? Cartesian coordinates in your ECM 103. Now, you are led to understand what we call the what? The intercept and slope when they teach you what? Equation of a line, gradient of equation of a line. The slope is same thing as what? As the gradient. Now, by intercept, let me draw the graph of demand. This is the graph of demand. Now, this price for quantity demanded. This is the price. Now, from this graph, the slope, I will start from the slope. The slope here is the what? Is the gradient of this what? Of this graph. The slope is the gradient of this graph, which will be what? Which will be change in what? In price over what? Change in quantity demanded. This is the slope. This is the slope. Now, what's the intercept? The point of intersection of this slope, of this line, on the what? On the independent variable, which is what? This point is the what? Is the intercept. Is the intercept. Is the intercept. Now, if we say our intercept is A and we name our slope to be what? To be B, then we can have our equation of quantity demanded to be QD equals to A minus BP. That is, the quantity demanded equals to the what? The intercept minus what? The slope times price. Now this is a what? This is an equation of this function. Now remember, when I started with what is the meaning of calculus, we are talking of what? A branch of mathematics that look at what? The integration and what? The differentiation of variables of studies. That's what we are talking about. Now, the variable of studies here is what? Is quantity demanded. So in calculus, what we are looking at is to what? Is to integrate this function, which is the function of what? The quantity demanded, or differentiate this what? This function of what? Quantity demanded. That is simply what calculus is all about. It is simply a mathematical branch that focuses, or that is concerned with the what? With integration and what? Differentiation of what? Of variables of study. That is differentiation of what? Or integration of the dependent variable function. So in case we are concerned with the quantity supply, the Qx is also a function of price. They are positively related. The higher the price, the higher the quantity supply. So here we have what? Qs equals to what? A plus BP. Now, the differentiation or integration of this equation in respect to this variable of concern is what we call calculus. So all we are going to do in calculus is to either differentiate or integrate variables of studies. So having understand what calculus is, we'll be going further by discussing the division of calculus. Recall from our definition of what calculus is, we said calculus can be defined as a branch of mathematics that is concerned with the differentiation and integration of variables of studies. So by that, even from the definition, the two branches of calculus as already shown. Calculus is largely divided into two. We have one. Calculus is largely divided into two. We have one, differential calculus, and two, we have integral calculus. Now, differential calculus is also called differentiation, while integral calculus is also called integration. With differential calculus, majorly what you are looking for is the what? Is the derivatives of functions. You can ask to differentiate the function, find or differentiate the function, or find the derivatives of the function. Because when you differentiate a function, the resultant of differentiating a function is called the derivative of that function. Derivative of the function. So when you are asked to find the derivative of a function, you are asked to find the what? The differentiation of the function. Why? Integral calculus, then you'll be in what? Integrating. You'll be integrating the what? The function. You'll be integrating the function to find the what? The integral of the function. The integral of the function is also called integration. These are the two major branches or division of what? Of calculus. Likely, I want us to notice this. This will be proved later in our studies. Differential calculus is a reverse of integral calculus. Why? Integral calculus is a what? Is a reverse of what? Differential calculus. What am I saying? What I'm saying is that when you differentiate a function to find the derivative of that function, if you integrate that derivative you've gotten back, if you integrate the derivative you've gotten from differentiating the function back, what you are going to get back is the what? The initial function you differentiated. You are not getting it. What I'm saying is that if you have a function such as y equals to 4s raised to power 3, given the function y equals to 4s raised to power 3, if you're asked to differentiate this function, what you are going to get is y equals to 12x squared. Now, don't ask me how I do it yet. We will get to know that. But let's just assume that this is what we have as the derivative. Remember I said when you differentiate the function, the resultant of that differentiation is called the what? The derivative. Now, given this derivative that we have, let's say if we have another question that we are asked to integrate this. Now, when we integrate this, what we are going to have is what? Is y equals to 4s raised to power 3. So what I'm saying in essence is that when you are given a function, if you differentiate the function, what you are going to get, which is the derivative, if you integrate that derivative back, you are going to get what? The function you differentiated in the first place, which means differentiation and integration are a reverse process of each other, and both of them have their distinct application in economics. They have their distinct application in economics. The knowledge of differentiation and integration is of great importance for a student of economics for their applicability to economic analysis and decision-making processes. Now we got into the last part of our introduction to calculus. Now here we're talking of the nature of economic variables. The nature of economic variables. Now remember when we define calculus, we say calculus is a branch of mathematics. Calculus is a branch of mathematics that focus on differentiation and integration of variables of studies. Now, variables of study, you're a student of economics. Definitely the variable you're dealing with it are definitely and most certainly they are what? Variables of economic nature. The variables of economic nature. Now, it gives me joy to tell you that the economic variable are not entirely the same as the variables you'll be looking at if you are in what? Pure sciences like chemistry, physics, because the focus of the discipline is different. So by that, we are concerned majorly here with the nature of economic variables. Why do I mention physics, chemistry? Because even there, calculus is an important tool of analysis to them. It's an important tool of analysis to them. But here we concern with calculus as it helps in what? In differentiating and integrating economic variables. So what is the peculiar nature of economic variable? Now, the peculiar nature of economic variable is that economic variable can shift positions. That is, economic variable changes over time. Economic variable can be disturbed. Economic variable are not static. The unemployment rate as at now, as I'm talking to you now, will definitely not be the same unemployment rate come December. I'm speaking October actually. Now, the unemployment rate, the inflation rate as at January this year is not the inflation rate right now. In fact, prices of commodities changes on a daily basis. Economic variable are not what? Are not static. For a salary earner receiving 100,000 every month, for a salary earner receiving 100,000 every month, the quantity demand for rice in January is different from the quantity demanded for rice in what? In February. As a function of what? As the prices of rice changes or as his income increases and other variables of concern there. So the nature of economic variable is that economic variables are not static, they are always changing. Now, a change in economic variable is a resultant of a change in the what? In their determinant. Remember, I discussed the independent and independent variable. And I told you the independent variable cause the dependent variable to change. The independent variable cause the what? The dependent variable to change, which means the position of the dependent variable is being disturbed by the change in the what? In the independent variable. What am I saying? Let's illustrate this using our supply curve. Let's have a supply curve of this nature. From the brief discussion we've had of little things I took you to under Cartesian coordinates, don't forget, when you draw the graph, you have to label it. The first thing we have here is what? Is QS, and the next thing we have here is what? Is price. Now, in this case, let our QS equals to what? Y, and let our P equals to what? X. You can have yours here. You can have yours here. You can make your PY. You can make your own PY. It doesn't matter. You can make your QS what? X. Still doesn't matter. It still doesn't matter because typically in mathematics, this is always the y-axis and this is always the what? The s-axis. But there's a change when it comes to graphical presentation in economics, because normally in mathematics, the y-axis is usually the what? The dependent variable, while the x-axis is always the independent variable. But when you are drawing your demand and supply curve, you realize that what? It is interchange, in the sense that the y-axis now we now have the what? The independent variable there, while in the x-axis we have the what? The dependent variable there. So don't get it confused. You can label it. You can label it this way. So this, we have x0, we have y0. Now, as the prices of this commodity increases, the price increases to what? To y1. So this brings the quantity demanded to s1. This brings the quantity demanded to s1. Let's say this point is what? Is point P. And let's say this point is what? Is point Q. Now, we have to observe something here. Now, the position of our price and what? Our quantity demanded is what? Is being disturbed, is shifting, is changing. The position of our price and quantity demanded is being disturbed. That is, it is what? It is changing in the sense that S, from the initial quantity demanded of S0, as prices of commodity increases, the quantity supply increases to what? S1. That is, there is a change in quantity supply, and the change in quantity supply is denoted by what? Change in S, which change quantity supply, which is empty as what? Change in S equals to what? S1 minus S0. Are we together? S1 minus S0. This new position of quantity demanded can be gotten as what? S1 equals to change in S plus now also with our prices also changes, and the change in prices here, we have change will be what? Y1 minus Y0. Y1 minus Y0. Now, for us to find what is this particular value of what? S1. That is, what is the new position? What's our new position of quantity supply, and what's our new position of what? Price. So the new position will be what? S1, making S1 subject of the formula here, will now be equals to what? S0 plus what? Change in S, Y1 equals to what? Y0 plus what? Change in Y. Are we together? Are we together? So by this, the initial position that we have before the shifting, which is point P, is what? Your x as point P is what? S0, and your y as point is what? Is Y0. But the new position here, you have what? S0 plus change in x, Y0 plus what? Change in y. Y0 plus change in y. This is simply the nature of what? Economic variable. Economic variable are not static. They changes position as a result of what? Disturbance. A change in the independent variable forces the dependent variable to change. A change in the dependent variable forces the what? The dependent variable to change. And graphically here, this has been illustrated, and this is the nature of economic variable. Here we illustrate it using the what? Our supply curve. Don't forget, this point here will always be the what? The intercept, and this here is the slope. We can have it here. We can further turn this to a what? To a triangle, such as here we will now be what? Changing x, and here be what? Changing y. Recall the slope. This is same thing as what? As the slope of the graph. The slope of the graph, which is what? Change in y over what? Change in s. Are we together? Are we together? So this is nature of economic variable. On this, we are going to finish the introduction to calculus. Furthermore, we start from discussing what is derivative, which is what is integral calculus. And from there, we're looking at the first principle of differentiations. And we'll be looking at all the rules of what? Differentiation. And thereabouts, we'll be discussing integration till we get to game theory, and we complete the entire course discussion for ACN 104. Thank you. Don't just watch. Thumbs up, like the video, and subscribe to the channel.